Okay, number 1. Do you have the derivative on top? No. So partial fractions. So you factorise first, split it up, and just go through your partial fractions as normal. Write your integral as 1 over 2 outside, integral of 1 over x dx, minus a half, integral 1 over x, add 2. You've got your derivatives on top, so just log the bottom lines. Number 2. Do you have the derivative on top? No. So watch the repeated root in there, the squared. So it's a over x plus b over x add 1 plus c over x add 1 squared. So just do normal partial fractions, but this time the b becomes 0. So this one disappears. So you are left with the integral of 1 over x plus that one disappears. And c is minus 2. So it's minus 2, the integral of this. This is a bracket, so bring it up as a minus 2. Do you have the derivative of the bracket in front? Yes. So you don't need to do anything fancy there. Add 1 and divide by it. Number 3. Use partial fractions because you don't have the derivative on top. Just watch the repeated root. X squared, x add 1. And just your normal way through that. Number 4 is asking you for the exact value. So you don't want a decimal answer. You don't want to use your calculators here. Do you have the derivative on top? No. So partial fractions. Through your normal way. Rewrite it in the separated fractions. And then log and stick your numbers in. So I hope that one's okay. Do you have the derivative? Well, that'll be a bracket. Do you have the derivative of the bracket? No. But also note, that's x squared and that's an x squared. It's an improper fraction. So I've got to divide through first. So you take the, first of all, times out the bottom. So you're going to take the top and divide it by the bottom. So take the top, divide it by the bottom. X squared goes into x squared once. Then you go 1 times all of these. Subtract. X squared minus x squared is gone. Nothing minus minus 2x is a positive 2x. Nothing minus 1 is minus 1. So just watch that. It's very easy to make mistakes there. Now rewrite it as 1 plus the remainder over the divisor. This is the bit now that's going to go into partial fractions. So you go over to the side with this bit and it's a repeated root. So partial fraction that bit. Now your expression becomes 1 plus a, which is 2 over x add 1, plus b, which is 1 over x minus 1. You want to integrate that, so just integrate each bit. The integral sign there, integral sign there. The derivative is a 1, so you want rid of that 2. Pop it outside. That's a bracket, bring it up as a minus 2. The derivative is a 1, and it's there, so you don't have to do anything fancy. So that becomes an x, log the bottom line, add 1 to the power, and divide by it. Then put in your 3, and then put in your 2. Okay. Number 6, I think is a very similar one. Repeated fraction, or repeated factor, sorry. So just your normal way, work out your ABCs. Rewrite this in terms of your ABCs. That one there's a bracket, so it was a minus 2, and the rest of it should be okay. Number 7, do you have the derivative on top? No. Partial fractions, there's nothing really to split up here, but it's an improper fraction. So take your top and divide it by the bottom. Take your top and divide it by the bottom. 2x goes into x a half times. So put your half up there. Half times 2x is x, and half times 1 is a half. Draw your line, subtract. X minus x is gone. Nothing minus a half is minus a half. So rewrite this as that's the number of times it goes in, plus the remainder over the divisor. Now tidy that up and put your wee integral sign in. So you're going to integrate a half dx, pop that minus a half outside, and you want to integrate 1 over 2x, add 1. Do I have the derivative on top? No. I need it to be a 2. So I've got to balance outside with a half. So that's that 2 appearing there, and there's another half outside. That one just integrates up to half x. This one's a quarter, and log the bottom line. And remember the derivative disappears. Put in your 1 and put in your 0. Okay, number 8. All right. This is a bracket. Do I have the derivative? No. It's not partial fractions. So whenever I'm completely and utterly stuck, I look at substitution. u is the awkward bit, so 4 minus x. Do du by dx, so it's differentiating du by dx, get minus 1. Bring this across, so du is minus dx, so dx is minus du. Rearrange this to get x equals, so x equals 4 minus u. Put all your bits and pieces in. So x is 4 minus u plus 4 over the square root of u. And dx is minus u. Remember your limits are still in terms of u's. Oh, sorry, x's. So we've got to fix that. So u is 4 minus x. So when x is 0, u is 4. When x is 4, u is 0. So just, and put your limits in the correct order. So the bottom limit is 4. The upper limit is 0. Tidying this up. Now, what this means is minus 8 over u to the half. So it's minus 8 times u to the minus a half. Plus u over u to the half. That's u to the 1. So 1 take away a half is u to a half. Add 1 to the power, divide by it. And put in your 0 and put in your 4. Very difficult one there. Right, number 9. Completely and utterly stuck just looking at that. So let's use substitution. What's the awkward bit? This. Okay. Now I wouldn't expect you to be able to figure that out on your own. You would need to be told that at this stage. You're just not there yet. So u equals log x. So rearrange it to get x equals. So e each side gets rid of your log. So eu equals x. Do du by dx. So differentiate that, you get 1 over x. Rearrange it to get dx on its own. Okay. Put those bits in. So it's 1 over, now I put in my x. I didn't change it just yet. Log x is u. And dx was x du. Can you see those cancel off? Leaving you 1 over u du. Do you have the derivative on top? I do indeed. So you can log the bottom line. Remember, your x's or your integrals limits are in terms of x's. So use your u to put them into u's. So when x is 2, it's log 2. And when x is 3, it's log 3. It's not a very unpleasant question. Putting in log 3. So it's log 3 minus log 2. They separate the logs, bring them together, just divide them. Very, very tricky question, to be fair. Okay, here's another very nasty question. You can see the awkward bit. Okay, e to the minus 3x. So let u equal e to the minus 3x. Now, you probably have forgotten how to differentiate a u, but to differentiate u, derivative goes in front, and the e function as it is. Sorry, to differentiate an e, derivative goes in front, and e function as it is. Rearrange that to get dx equals. So write that as 1 minus u over 1 add u. Put your du in. This here is u, so it can be written as u again. This is an awful question. Combining this, now what I've done, see this minus? I brought it up to the top just to tidy that up. U minus 1 over 3u times 1 add u. I also fixed my limits here as well. Okay. Have to integrate this. I don't have the derivative on top, so I have got to use partial fractions. That's me using the partial fractions. Now splitting this up, subbing in your u's, and see how you work through that. Very, very tricky question.